So we're going to continue where we left off from last week's lecture, discussing state management. So I'll give you guys a sort of refresher of what's going on here. So the state of a website combines two things. It's the state of the local application or the copy of the web application that's running locally in the browser. And you can see all your state variables in the top left here. So you can see I just visited this website. So I have no state. You can see there's 0 cookies in use. There's no variables that are stored unique to me on this browser yet. However, as soon as I click login, you can see I've now got 2 cookies in use. Okay, so I've now got 2 cookies in use. So as soon as you start using the site, a whole bunch of variables are updated to keep track of what's going on your side of the site. Okay, so that's the state. Ooh, yeah, what's up, Taffy?
What are the cookies?
We'll cover them in more detail now. They're just a special kind of data structure that's storing some information on you. It's not, they're not super nefarious as you might expect from like sort of news articles and stuff, because they're used for everything. Like my name here will be stored in a cookie. This will be stored in a cookie. You can see all of the cookies that are in use up here. So we've got a CSRF token. So this is a token that we store locally. And the server knows this CSRF token. And if you give them this CSRF token, like the clients, like my browser, goes ahead and gives the CSRF token to the server, then it knows that I am logged in. The server knows that I'm logged in. The session ID is how the server uniquely identifies us. So obviously there's lots of people using the server at once. So the server gives each user that's using it a session ID so that we can be uniquely identified. And yeah, so messages can be a whole bunch of different things. So this was the last message that the server sent to me. The last message it sent was successfully signed in as one, and then my email address, my student email address. So, and you can see that's the email address I used to sign in. So that was just the last message that it sent to me. So those are the kinds of things that are stored in cookies. Obviously, you can store other things that would allow you to, like, hypothetically track people, for example. In fact, if we go to, what was it, bfmta.herokuapp.com. So the site, when it eventually wakes up, bfmta-staging.herokuapp.com. Cool. So yeah, there's a whole bunch of different things that we can store in the state. But yeah, so we'll leave it at that for now and go more into detail now. So we've got these two sides of state management, right? We've got client-side state management, which is the things that I'm storing. And we've got, we changed it back from the IP address to the username. Oh, well, okay, that's fine. So we've got client-side state management, which is the things that I am maintaining about the state. And we've got server-side state management, which is the variables that the server is maintaining, right? So there's a bunch of different ways to handle both client-side and server-side state management. But basically, it's just how do we pass around variables on each of these sides? How does the server keep track of different variables? And how do we, as the client, keep track of different variables? So there are 4 ways we do it on the clients. It's on page 100 of the textbook, which in the chapter 4 PDF that was sent on the WhatsApp group. Tsecho, you made it. I'll try to remember to add you to the register maybe during the break or something, okay? Cool. Glad you're here. Okay, so client-side state management. We were just doing a refresher up till now, so you haven't missed anything yet. So client-side state management, this is how variables are maintained on the state. So the first one we must discuss, a very common, very simple one, is called a query string, a query string. Now, you guys know what strings are, right? They're things that are stored inside quotation marks, right? Just an array of characters, basically. But query strings can also be used in websites to pass around information. So a very common place to use query strings is when you're searching for something. So for example, if I search Lewis, okay, so look at what the URL is currently. You see it's edussess.co.za/library, okay, /library. When I click search, okay, you see what it becomes. It becomes edussess.co.za/library/search, okay, so that's fine. And then it goes question mark Q equals Lewis. Question mark Q equals Lewis. Okay, so that is what I am currently searching for. Okay, guys, and you can see that if I change this to, for example, Jane, okay, you can see that I'm now searching for Jane. So how this is being stored, how whatever is typed here is being stored, is in this query string. Okay, we can also search for Grim. Okay, so whatever you're searching for is being passed around by this query string, and that's all a query string is. You can pass around any string in this way. Now, this might look weird to you guys. You go like, oh, but this doesn't seem too secure or whatever, but this is the standard way of doing it. So it's not just this site that is doing it. We can also go check out Google. Google is doing the exact same thing. So we can search for, let's search for Grimm's Fairy Tales in Google, okay? So you can see, so it goes search question mark Q equals Grimm's Fairy Tales. That's the search. All of this after stuff is not relevant. And if we change what we're searching for here, like we could also search for edge assess. So we could also search for something else, and you can see that it brings up, it allows us to search for that. Okay, even just adjusting the query string here. Okay, if we say YouTube, it'll also search for YouTube. Okay, so the query string is how even the most professional sites in the world will just use a query string for this kind of thing. So that's what query strings are used for. Whenever you're not storing sensitive data, I can give you another interesting use, but again, it's just a standard string, okay? So you can see if I go login, so from the home page, I click login. So you see I'm on the home page. If I click login and I sign in, then I get rerouted to the home page, okay? However, if I click on, if I want to go into a book, like I want to go into a book, I have to be logged in to view a book, okay? But you see it says question mark next equals library. So this is the URL to the book. So if I sign in now, because that query string is set, that is the URL that I will be rerouted to. Okay, so if I click sign in now, I'm not rerouted to the home page, I'm rerouted to the book. Okay, so that's the kind of thing that query strings are used for. And yeah, so they're used for that in like all kinds of different contexts. Okay, cool. So whenever you want to pass around a string inside the URL, you can just put a question mark in front of it like that, and you can just say question mark Q equals whatever string you're passing along. Okay, cool. So that's that. That's query strings. Pretty simple, I think. Next is cookies. Okay, so cookies are small packets of information stored by your browser on your computer. We've already kind of discussed all of the different cookies that this site uses, but you can see that they're all dated as well. So like the CSRF token, you can see I'm logged out now. Okay, I'm logged out now, but I still have my CSRF token. So the browser would just give the CSRF token to the server, and the server now knows that the CSRF token is logged out. Okay. So yeah, that's usually the kind of thing, any sort of personalization. However, it's not secure. Okay, so like a website is not going to store your bank account details or something in a cookie. Okay, it'll only store things that are kind of like allowed to be seen, essentially. So like personal information that's not sensitive, that needs to be maintained across logins. And what we mean by that is, so like a query string, obviously, you can see if I set the query string here, so if I search for like Lewis, you can see that the query string over here is not going to be maintained if I close the session. So you can see I'm logged in. That's being maintained by a cookie. The query string is being maintained in the URL. If I close this, okay, so if I close this page now and I open Edge Assess again, you can see I'm still logged in, but the query string is obviously gone, right, as you'd expect. And like even the query string won't even be maintained across pages, right? Like if I search for Jane and then I click on my library, you can see the query string's gone, obviously, because the URL changed, but the cookie stays. So particularly when you need to maintain non-sensitive information across multiple pages and through multiple browser sessions. Okay, so even if you close it and reopen it, you can see I'm still logged in. Okay, that's what cookies can do for you. Okay, we'll see an example of sort of like how cookies are processed. You guys have already seen dictionaries before, that data structure we covered at the end of chapter 3, that like weird one. That's all a cookie is. It's just a dictionary essentially. That's how it's maintained. But we'll see the server side aspect of cookies later. So we call it a cookie over here, but on the server, it's something different. Okay, so, but I'll discuss that difference and we'll see some examples of it in Visual Studio. Okay. Next, we have hidden fields. Okay, so hidden fields in HTML. This is not used much. It was used more sort of historically, but you should know that that they exist. Okay, so you can see I've got 2 text fields here. So this text field is currently storing this piece of information, right? It's storing 147370 at students. That's what that's storing, and this is storing some sort of password thing. Okay, if I hit inspect over here, okay, so I'm going to hit inspect. Okay. You can see all of the elements that are on the page. I'm just going to go ahead and find this little login field here. Okay, so there we go. I've got the login. There's the login form. Okay, here's the password field, and here is the email field. Okay, so you can see I'm storing some information in this text field, right? Kind of similar to welcome Chico. Glad you could make it. Cool. All right, let's just remember to add both of you guys. I guess Yusuf couldn't make it today. So cool. So we've got our email field here. You can see that I am storing information here, right? Like hypothetically, I could store some data in this field as long as I wanted, right? As long as the user is on this page, I could store that email address there, right? But the problem is that currently the user can see it. It doesn't look too great. Like obviously, if I wanted to store this without the user knowing I'm storing it, like just to keep the site neat, not to hide things from the user, because fundamentally they can still just open this and see it, like inspect the HTML. So this is not a secure way of storing information, but it is a way to store information. So let's say I wanted to store this email without the user knowing, just to personalize things in some way. Then I could change type. You see type is set to text here. If I just change that to type equals hidden, okay, you can see that the email address is now gone. You can see that the type of the password field is type equals password. I could also change that to type equals hidden, and you can see the password field is gone. Okay. Now the email address is still stored. You see that it's still storing the email address there. It still says there's the email. So I could still get that value, right? Like it's still stored on the site. It's still stored on the web page rather. Okay. And I could even change it. Like I could, if I wanted to store a different email, I could say Josh at. You can see it's stored there. You can see if I change it back to text. So I'm going to change the type from hidden to text again. So now you'll be able to see it, and you can see the email is now josh@students.wits.ac.za. Okay. So hidden fields are just a way to store information on a web page. Okay. We don't usually use this. The reason we don't partially is number one, just like a query string. So number one, it affects your page formatting and your page templating. It's not a great way to store things. Like, as you can see, this is it seems pretty silly. It's not very secure because obviously anyone can just inspect. Like you could just right click and hit inspect, and then you can see all the HTML and you can find all the hidden fields. And number two, it's just not like when you refresh, like when I refresh, you can see that the hidden fields, the values would change, right? So you can't store information across page postbacks, and you can't store information across browser sessions. Like obviously, if you close the page and reopen it again, then the hidden field is gone, right? It's reset. Okay, so cool. That's just a hidden field. You can take a text field, you can mark it as hidden, and then you can store data on the page. Again, not used a lot nowadays, really, but historically it was more common. Okay, the last one is one that's pretty unique actually to Visual Studio. So can be used to maintain this. It's called the view state, and whenever you want to store page specific information. So it's kind of, in a way, it's actually kind of similar to query strings and hidden fields. In fact, it is stored as a string by C#. And so there are some ones that I want to cover more in detail later, but essentially the kind of thing that a query string allows you to do. You can see that I type RAM there. Okay, so I've just got this little GIF. I guess we can see it now. There's no harm. We'll do some query string stuff. So you can see I typed mirror, but mirror is gone from the page. I type RAM. RAM is now gone from the page. But when I click display value, you can see it still knows that I typed RAM, right? I type mirror, mirror is gone. But when I hit display value, it knows I typed mirror. Okay, similar to how a hidden field is working is how this view state is working as well. Okay, and essentially, yeah, it's very similar. It's just something that C# provides. I suppose we can do a quick demonstration since we'd probably I think it's best. Let's instead focus on doing the session states example. Okay, we're going to focus on doing a session states example. Yeah, because I think it's more beneficial. But yeah, essentially the view states, it's just like a hidden field. You can imagine you saved a hidden field there, and when you click display value, it just displays the hidden field, for example. So you could do this in multiple different ways. But the view states, if you ever want to store page specific information, you can type enable view states equals true in Visual Studio, and then you can use that view state. I suppose we. Yeah, it's not super common, especially not outside of C# or ASP.NET. Okay, but maybe we can demonstrate it if we have time. Next, I want to get into server-side state management, though. So what I'm going to do quickly is I'm actually just going to create a quick web form so that I can demonstrate this one to you sort of properly. So I'm going to hit create new project. Okay, we'll call this MTA Saturday 04. Yeah, we're in chapter 4. So workspace is cool. We'll just hit create there. Okay, so I'm just creating a quick Visual Studio project so that I can demonstrate some stuff to you guys. Okay, cool. While that's creating, so there were the 4 kinds of client-side state management, and there's 2 kinds of server-side state management. So the first is called the session state, and you can see the session ID. So all web frameworks do this. I can just show you quickly just to remind you guys. So you can see over here, we have, because we're not logged in, we don't have one. Let me just log in quickly. There we go. And now we will have one. Sorry, that's the certificate. Let me just open this. Okay. So you can see that I've got a session ID here. So this ID is uniquely identifying my session. Like if you copied this ID, even the CSRF token, then you could steal my session, hypothetically. You could steal my session, assuming it's not linked to my IP address by the server. But yeah, you could hypothetically steal my session ID and then steal my session. Which is like a very common way to sort of do to hack someone. But anyway, the session ID is what's uniquely identifying me on the server. So you can imagine I'm maintaining some cookies over here, right? Like on my local machine. And on my machine, we call them cookies. You can see all of these are cookies, okay? Now, on the server, they aren't called cookies. They're called sessions, okay? Because the server uniquely identifies each person with a session ID, okay? So basically what we call cookies on the client side are what we call sessions on the server side. So if you're asked as a developer, how do you store people's private information on the server so that it can be preserved across pages, multiple pages, you will answer session. You will not answer cookie because you as the developer will be using something called the session. when you pass that session to the user and the user stores it locally, they'll call it a cookie. But you call it a session, and you'll see why we call it a session now. It's because of the variables that we use to store them, and because they're uniquely identified with a session ID. Okay, so I'll give you a little demonstration now of what we can use the session state for, and we'll see now. So I'm just going to add a sort of web form to this web application quickly, just so that we have somewhere to place this little example. And yeah, we'll get cracking on that. Cool. So I have a basic website here. And essentially, I suppose what we can do is store people's name. I think it's a fairly good one to store people's name. It'll give us a nice little example of like a practical thing that we can do. So what we'll have is a button, a text box where you can type your name. And actually, let's just have a label that says your name and a text box where you can type your name and a button that you can click that will send your name to the server. Okay, so cool. Let's get cracking on that. We can create it quite quickly. So we're going to be using the ASP.NET labels. So I'm going to say ASP label. This is kind of like an HTML paragraph tag, essentially. We say we need to give it a unique ID so that we're able to identify this label on the server. So ID equals label 1. We want to be able to access it on the server. So we're going to say run at server. And we're going to give it some text. Its initial text when you access the site is just going to be, please enter your name. Okay, please enter your name. Okay, something like that. Great stuff. And we just need to close that tag now. We're going to have a text box where you can type your name. So text box. The ID of this, we'll just make text box 1. It's also going to be run at equals server. And it's not going to have any default text because we are going to be rendering this in Microsoft Edge. And it has this unfortunate thing that when you have default text, you actually have to backspace it, which is very annoying. So just no default text in the text box. It's just going to be an empty text box. We're then just going to have a button that you can click. So ID equals button 1. Then we'll say, OK, run at server, run at equals server. Text equals, we'll say submit for now, but we'll change it later. And for now, we'll leave it at that. OK, cool. So I've got a label, a text box, and a button. Very simple application. I'm just going to build this. So I'm going to right click, hit build solution, and then I'm going to open this and view it in my browser. OK, after the build is finished. So you see it says build started. It's building, it's building, it's building. Going to take a little while the first time round. OK, it's finished building. And you see it says build succeeded. So there was no errors. I'm then going to say right click, view in browser, and that's going to open it in the browser. So now, guys, you'll see that this won't look great. You guys know, though, if I wanted to style this HTML document, what would I use? How would I style this HTML document if I wanted to style it? Because you can see that it's not going to look too great now. How would I style it if I wanted to? What would I use? What language would I use? OK, so that's what it looks like currently. Not too great. I suppose we can push things to a new line. Should we push that button to a new line? Let's do that. So while you guys answer that, how would we style this web page if we wanted to? Ooh, by the way, did anyone create a website by following the tutorial? If you want to share, then please post in the chat and then we can check it out during the break. OK, so I just added some break statements to push that to the new line. Does anyone know? How would we style this if we wanted to? How would we style it? So you can see currently when I click submit, it doesn't do anything. Anyone? What language would we use if I wanted to style this HTML document? What language would we use? CSS. Yes, exactly. Nicely done. Cool. Glad someone got it. Great stuff. So you can see that currently nothing happens when I click submit. So what do we have to do when I click submit? What will I use to implement this button, guys? When you click the button, something must happen. What will I use to implement that idea? What sort of what would we call it, programming structure would I use to implement this button so that when I click it, it actually does something? What do we call them? Does anyone know? What am I going to add here to implement that button? And let's go through the list. Wow, there's a lot of attributes here. Any of these guys? Does anyone have any ideas? How a link? Not bad. I mean, so which programming structure do we use to say when something occurs, something else must happen? Okay, does anyone see anything on this list? Okay, so Chris says an event. I want to go even further than that, Chris, but yeah, you are right. That was the answer I was looking for. But let's go even further than that. I want one of you to tell me which option am I going to use in this list? And you see it's a long list. Which option am I going to use to implement this button? Anyone have any ideas? Wow, there's a lot of options, hey? Which option on this list am I? Hey, Tejo, nice. Yes, exactly. That's 100% correct. Yeah, so we're going to say on click. Okay, so on click, I'm going to set its value to a particular method. So I'm going to say, okay, when you click the button, we're going to run a particular method. So it's going to be like button1 underscore click. Okay, so when you click button 1, so you see the ID is button 1. When you click button 1, it's going to run this method called button1 underscore click. And I could call this method whatever I want. Okay. And then what I'm going to do is I'm going to jump into the CSS code sort of behind this page, which is here. And I'm just going to add a method called button1 underscore click, okay, whatever the name of the method I set on click to. Similar to how the JavaScript was working, except this time it's C# code, okay? So we're going to say button1 underscore click. It has like a basic format. So we're just going to say object sender, event args e. This is just the formats of all of the web events inside .NET. If you want to look into it more, you're welcome to. Okay, cool. So there we go. Now this method is going to run when we click it. And in order to just make sure that it's running, let's say response.write. And I'm just going to say button1 was clicked. Okay, button1 was clicked. Okay. So for now, we're just going to double check that Tejo's suggestion was correct, and we'll just see whether or not this button is actually running now. See, I'm putting moving the blame a little bit. I'm kidding, but yeah, hopefully it'll work. So you can see, ooh, okay, I'm gonna reopen it in a fresh page because I'd already clicked the button in that page. So we're gonna open up view in browser. There we go. Okay, here we are. I'm gonna click submit. Button 1 was clicked. Cool. So you see, it's effectively writing to the response now when we click the button. Okay, cool. So that method is running, but it's currently not doing what we want it to do, obviously. So what do we want to happen when you click this button? Okay, when you click this button, it's going to change this. It's going to be a very silly site. It's not going to look great. But what we're going to do is change the value of this label to be whatever you typed in here. So if you typed Ali and you click submit, then it's going to change. Please enter your name. It's just going to say hello, Ali instead. Okay, I'm going to put a break line there as well because it'll probably look better in that way. Okay, so I'm just going to add another break between the label. So I'm just going to say break over here. So break just means create a new line. That's how we do that in HTML. So I'm just going to add a little break between the label and the text box. Okay, cool. So what we're going to do, this is going to button1 underscore click is going to use, it's going to create a session for the user. It's going to create a session. And how do we match up the sessions? We have that session ID, which the browser and ASP.NET will automatically handle for us. So how do we do this? We just say, okay, session in a position, so like name, for example, and you see this is a dictionary, guys. So we're going to say session name equals whatever is stored in text box 1 dot text. Okay, whatever is stored in text box 1 will be the value of session name, and then we're just going to say, okay, when you click that, we're going to change label 1 dot text to whatever is in session in position name. Okay, something like that. Okay, pretty simple functionality for now. Ooh, let me just see. Will we have to say like .toString or something? Yeah, .toString, probably. Yeah, okay, cool. That's fine. This is a very simple way of doing it. So all I do is I add to the session variable. I add a name to the session variable. Whatever you type in textbox1.text, and then I set label1.text, which remember label 1 is the ID of the label on the page, to whatever's in session name. We have to say .toString just to make sure that it's a string, because obviously label 1 expects some text back, right? So I'm going to say build solution. Hopefully this works okay. Ali submits, and you see it changes to Ali. Okay, if I type, who was the last person to type? Okay, if we make it Tejo instead, then we hit submit. You can see it's Tejo. If we make it Chris, then it'll be Chris. Okay, so that's working okay. And yeah, you can imagine you can do a whole bunch of stuff with the session variable, but essentially it's just a dictionary. So you guys remember when we said session cat equals when we created a dictionary inside Rex test and we said like whatever in position cat to domestic feline mammal, like we made that in thingy. So then if you accessed session in position cat, now it's going to print domestic feline mammal. Whatever you type in the text box, it's just going to print domestic feline mammal, which is just the definition of the word cat. So this is exactly how dictionaries are created, which is why this data structure is called a dictionary. So it's just that your key is also a string. So you see it now says domestic feline mammal. Okay. It's a very silly example, but just to illustrate the points. Okay, so this is just a standard dictionary, and you can do whatever you want with it. Okay. Anyway, so that's the session state, and it allows you to store things across multiple pages, and you can do a whole lot of different things with it. And actually, if we check this, cookies in use, localhost cookies, you can see we've got an ASP.NET session ID. So that is our session ID for this particular session. Okay. Okay, so that is the session ID for that particular session. Okay. Cool. So we could also, if I go take this across here, interestingly, that's a bit weird. Let's see. Okay, hold on. If I refresh, okay, it's because it's only changing with the button. I could demonstrate that to you guys as well. Let me just do that as well. So I'm going to say so we're going to check if the session is set inside the page loader. So I'm going to say if session in position cat does not equal null. Okay, I know this is getting a bit crazy. We're really taking this example too. So this is saying if session cat is set, then set label 1 to whatever is in cat. So set label 1.text to session cat .toString. Okay, so like that. Now, so all this is doing is it's saying whenever we open the page, if the session cat variable exists, then just set it. Okay, so I'm going to open this up and just go into view in browser. So what you'll be able to see, so we open submit there. I'm going to copy this across. You can see that because my session variable is already set, doesn't matter how many times I open this page, because the session ID is already set, that cat variable is already set. So it can be so what are we being asked here, Taffy? When I don't know what injayam is. Mina Grand. You are Grand? What?
Oh, sorry, sir. I was just talking to my brother.
Ah, okay, cool. Okay, so cool. That's the session ID. Great stuff. Next, the other thing that I want to talk about quickly is just the application state. So you can imagine, so these are the two kinds of server-side state management. You've seen the session state now, but the application state is very similar, okay? It's just that, it's a sort of simple difference, actually. So you can imagine the session is storing a unique thing for each user, right? So I'm logged in here currently. I have my own session ID. If you log into the site, you will get your own session ID. That's different from mine, okay? We'll each have our own session ID. So the server is storing a session for each of us, right? So for every single one of us. But you can imagine that the server would also want some information that is universal, right, for all the users. So for example, if we were keeping track of the number of users currently accessing the site, right? So let's say there's 4 people currently accessing the site, then we would want that number to be 4. You see that that number is not specific to any user, right? It doesn't make sense linking it to a session, right? Because the session is specific to every single user. It doesn't make sense storing a variable that is universal to the whole site in a session, right? Like, for example, the number of active users. So what we have for that is application state. So this stores information that is used by the application as a whole. So like the number of active users, the number of users currently logged in, the last time a user logged in. All of that stuff is universal to the application. And by that, I mean the last time any user logged in, not the last time you specifically logged in. But like any information you can picture that is universal to the application as a whole, okay? Rather than to a specific aspect of the application. Then we store it in the application state. So we have the session state to store user-specific information, and we have the application state to store application-specific information. So information specific to the application as a whole, like the whole website. So the best example of that is the number of currently active users, okay? That would go in the application state. Cool. And that's actually it for state management. Those are all the ways that you can track and store personal information for users, okay? Those are the 6. All right. Obviously, you can also save stuff to your database, but that's not really state management, that's storage, okay? And we covered databases in chapter 6. Cool. So that is that. Okay, that is actually that for ASP.NET. The next thing we cover is web services. Okay, so let's jump into that. Can I just add? No, I don't think we can. So we're going to say file, new project. No, I think we can do it just here. Let me just double check. Sorry, guys. I'm going to say we want to add like a web service to this. Ah, there we go. Got one. Cool. Okay, we'll come back to this now, but let's first get an intro into what web services are, and then we'll continue with that. Okay, so we've discussed websites, so we sort of understand what's going on the client side. There we've got HTML, CSS, and JavaScript. And on the server side, we have like whatever framework we're using. It has some kind of page lifecycle that it uses to respond to certain requests. And we've also got different kinds of state management. So that's what's going on the server. But there's another whole aspect to how websites operate. So to illustrate this, I'm just going to give you guys like a basic example. Okay, so well, okay, yeah, okay. Before this, let's discuss how you like actually manage a website, simply because that's the flow of the site as well. So this does make sense to cover it this way. So on Windows, we can manage whatever web servers we want. It's called IIS. This comes default on all Windows computers. You can use this to turn your computer into like a little web server, okay, so that other people can access your web server. You do have to activate it. So if you go into add and remove programs, you'll be able to activate it before you can search for it like this. But this is default installed on everything. We're not going to discuss it too much in detail because there's other ways you can create web servers as well. Like the one I sent you was Google Firebase in that tutorial. Hopefully one of you goes ahead and makes that your own like personal website, because it is quite a nice thing to have. But yeah, so IIS is just one way of creating web servers. But let's just go into detail one last time about like what a website is, because that's sort of what we've been clarifying for the last while. So we've learned about websites. There's this client side and this server side, but let's discuss what is a website actually, like on a formal definition. So a website has two parts to it. It has web applications. So for example, it'll have a login page, right? Like a login page might be a particular application. The reader, like on this site, there's an e-reader, right? So like you can open a book and you can read the book. So that's a particular application. And yeah, so websites have web applications. Okay, so a website has a bunch of web applications. And it also has so web applications are just an application that runs on a web server, and you know what an application is from chapter 3. And then it also has virtual directories. So we haven't discussed this in a great deal of detail, but it doesn't take long to really describe. So you guys know what this is in the top left here. Like, what do I call this? What do we call this whole thing that we have in the top left here? Do you guys remember? What do we call that whole thing that we have in the top left there? Anyone remember? What is that called? La 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 la. A URL, exactly, a uniform resource locator. So so that's our URL, right? Now, so what this is the protocol that we're using, HTTPS, so like the secure version of HTTP. That's the server that you're accessing. And this thing that comes afterwards is the path, okay? The path on that server. Similar to how a path works on your computer, right? Like, in fact, if we check it out here, like if we open the little web form that we created earlier, if I say view in browser, you can see that this is accessing localhost / webform1.aspx. So that's interesting. It is accessing a path there. It's saying /webform1.aspx. But where is this? Where is webform1.aspx? Let's actually find it on my computer. So if I go to my desktop inside Workspace, that's where I was programming. That's where I told Visual Studio to save everything. MTA Saturday, web application 1, there's webform1.aspx. So you can see the path on my computer is actually this. It's C users, user, desktop, workspace, MTA Saturday 4, web application 1, webform1.aspx. That's where webform1.aspx is saved on my computer. But you can see in the browser on when we try to access the server, so the server is my local computer, localhost, that's my home computer, and we access just /webform1. So how does it get from /webform1 to users, user, desktop, that whole long URL, that whole long path we saw before? How does it get from that? This is called a virtual directory. Okay, so when we say that this is the path on the server, usually it's not actually a path. Okay, like there is no folder on the server. There is no folder called library, and there is no file called 3b7, that whole long thing. There's no file with that name. Okay, so what's happening here is that this path is pointing to a path that actually exists on the server. Okay, and it's doing that through a virtual directory. So this path virtually points to an actual path on the computer. Okay, similar to how like a shortcut works on your computer. Like if you open one of these shortcuts, it points to an actual executable file for it. The shortcut is just symbolically pointing to that other place. That's all a virtual directory is. So a website is just a bunch of web applications and virtual directories. Formally, that's all a website is. Okay, and you can manage these sites and virtual directories through the IIS Manager tool, that little thing I showed you before, Internet Information Services. So that's what a website is formally. That's what we've been learning about for a while. And so, yeah, those are just the two components just discussed in a little bit more detail. But there's another sort of component that's outside of this. There's another sort of way of thinking about how clients interact with servers. And we call these services. So to give you an idea of what a service is, let me just sort of give you a brief rundown, okay? And we should be able to, let me just see, what is the time? Okay, 9:51, we'll take a break at 9:55. So what is a web service? So web services are software components that can be accessed over a network. Okay, so software components, that's just another way of saying services, and can be accessed over a network. By network, we basically mean the web, right? Because that's like the father of all networks. It's the big network. Okay, so cool. Just that formal definition isn't particularly helpful. So I'll give you an example of what we might use a service for, or like a standard example of what you might understand as a service. So we've got you here, okay? That's you. You're going to this authentic German restaurant, okay, called Schnitzel House. Now, it might look like they can speak English, but at this particular German restaurant, they're so authentically German that they don't actually speak English at all, okay? The chefs at this restaurant, the cooks at this restaurant, do not speak English. So if you want to make an order, you'll say like 9 drinks, please, and they'll be like nicht was, because, you know, 9 just means no in German. So they have no idea what you're saying, okay? Like these German chefs have no idea what you're saying. So guys, how would we solve this problem in the real world? Like if you saw this problem happening in the real world, how would you solve this problem? You're trying to order some food from this authentic German restaurant, but they don't speak English. You only speak English, they only speak German. How do we solve this problem? How do we solve this problem in the world? Anyone got any suggestions? Like, what are we going to do here? Google Translate. Yeah, that's a very 21st century solution. Use an app made for this, a translate app. Yeah, you guys are all thinking in very 21st century solutions. I mean, I think practically, historically, if we were thinking of like an actual restaurant, we would probably hire like a waiter, right, who speaks both German and English. But yes, a translate app could work too. Right, we would have like this interpreter, right? Something that can interpret between me and the German restaurant. Okay, so that's sort of what this example is setting up, and this is basically what a web service is actually. So if you replace the restaurant with the server, and you replace the waiter who speaks both German and English with a service, then you know what a web service is. This is essentially what it's doing. Okay, so the web server, for example, might only be able to speak in C#. The web server only knows how to speak in C#. If you give it an integer, it must be a C# integer. If you're requesting a method, it must be a C# method. The server only knows C# or Python or whatever language, okay? You as the browser, right? You as a browser, you're a client accessing things through a browser. You only know how to speak HTML, CSS, and JavaScript, right? You don't know C#. You don't even know C# exists. You have no idea what's going on. You only know how to speak in like markup languages. Maybe you understand XML as well, okay? So you know a couple of languages and the web server knows different languages. How do you communicate? The answer is a web service, okay? The web service will translate between what you speak and what the server speaks, and it'll translate the response as well, okay? So formally, what a web service will allow you to do is it allows you to access the functionality of classes and methods on a remote computer, okay? Remote computer basically just means server, without necessarily knowing the language that they were created in, okay? So even though the server only speaks C#, like our German chef only spoke German, weird English there. And yeah, and you only speak whatever language, so English or HTML, CSS, and JavaScript, the web service will be able to translate between you, just like the waiter. Okay, so what is this actually used for in the real world? So let's just go through like an example of where a web service might be used in the real world, okay? So you can be anything. You can even be a web server or another application or just yourself. You can be anything. So You're very, very motivational there, I think. But like, what might this be used for in the real world? So like a very common use case, like a nice example of where we use web services could be like if you're looking for a flight. So let's go to a site. So trip.com, that seems good. Flights.com, that seems good. One of these sites will have a nice sort of format going. Okay, that's all in find best flight deals. Let's go. Okay, so this is searching for a bunch of flights, and we'll see what response it gives us now. Okay, so here's the response that it's given us. Cool. So we have Han Air Systems. Geesh. Okay, let's find a site that has a couple more airlines available. So that place hasn't been using enough web services, I think, is the problem. I know of one example that is pretty good. Let's say a flight. Okay. Oh, okay, look, Google is doing it here for us, so that's pretty cool. Wow, Google really is monopolizing everything. That's quite scary stuff. Anyway, so you can see Google's gone and fetched a bunch of flights here, okay? So it's got Fly Safair, so that's one airline. It's got Airlink, more Fly Safair, more Airlink. Oh, did Google only get flights from Safair? Oh, we've got some Mango over here. Okay, cool. So we've got at least 3 airlines here. Cool. So we've got at least 3 airlines. That's pretty good. Yeah, cool. So that's fine. So we've got 3 airlines. We've got some pricing. Cool. So what do you think happened here? Do you think Google has direct access to Safair's database, guys? How did it get this flight? And does it have direct access to Mango's database as well? And Airlink's database as well? That seems pretty ominous, right? Like if Google actually has direct access to all of these companies' databases. Do you think that's likely? Probably not, right? That's probably not what's going on here. So what actually happened here is that Google used web services. Okay, so Airlink has a server somewhere. Okay, Airlink has its own databases. It has its own server somewhere that's got all of its flights and flight times and flight prices. And what Airlink did was make a web service or API that allowed Google to query their database. Even though Google doesn't speak the same language as whatever Airlink's database is programmed in, even though Google doesn't have direct access to Airlink's database, they are able to query Airlink's database through a web service. Okay. Another good example of this is YouTube. Like you can query the amounts of views that a YouTube video has, right? And yeah, so that will be done through a web service that YouTube has made available. Okay, so this is what web services are used for. So you don't have to give everyone direct access to your database. You can just publish a web service and anyone who wants to use it can. Okay, so Google used it here. Okay, so in this case, Google was you, okay, or like this you was replaced by Google. They used the web service to communicate with Airlink, Mango, and Safair's database, and the web service translated the response back into a language that Google understood. Okay, so how do these work? It uses a language called XML, which is Extensible Markup Language, and it's transferred over HTTP. Why does it do this? Everyone knows how to speak XML. It's like the simplest language. You'll see it later. You don't even have to be taught it. You can just read it. Any human is able to read it. Likewise for computers. It's a very simple language, and you can always figure it out. HTTP is the protocol that we use to transfer stuff, right? Like everything, if you have a browser, you know how to understand HTTP. If you're a server, you know how to understand HTTP. So the reason they use this is because of broad compatibility, right? You can see it there, broad compatibility. Basically, everything knows how to speak these two sort of ideas, okay? So with that sort of covered, that's what a web service is. We'll come back and understand it more practically later. But I did go a little bit over what I said our break time would be. So let's take a break now. We can do, are we going to do 10 minutes? Yeah, sure. Why not? We'll come back at 10:10. Okay, guys. I mean, 10:10. Okay. Ooh, let me post that in everyone. We'll come back at 10:10. Okay. Let me just stop sharing so that I can add Tejo to the register. without giving away everyone's private information to YouTube. Okay, let me just find the where did it go? Virtual classes, is it called? There we go. Okay, so got yes, and should add Chico to the other one as well, to the Bryanston one. Oof. Okay, cool. Start sharing again. Okay, I'm going to run and grab a glass of water. Feel free to post any questions or something you have in the chat as well. Cool, I'm back. I'm going to try something out quick. Ah. Cool. Let's get started again. Okay, so what I'm going to do is show you guys a simple example of a web service, and then we'll discuss a little bit more in detail what it is it's doing. Okay, so web services are actually pretty simple. I think we should be able to get through them in the next sort of 50 minutes or so. And that'll bring us to the end of chapter 4, actually, which, yeah, cool. So a web service is, at least in C# and ASP.NET, how it's created is very simple. It's basically just a C# method. So you can see that I'm inside a class here called web service 1, right? You can see I'm inside a class called web service 1. It's inheriting from system.web.webservices web service. And you can see that it's marked as a web service, okay? So the class is marked as a web service. What that means is that any method inside this web service class, if it is marked as a web method, will be available through the web service. So I'll give you an example of that now. So I'm going to say, I'm going to mark the thing as a web method, okay? And then I'm going to say, okay, we'll create a simple web service here. And then, what we'll do, what web service shall we create? Should we create a web service sort of, maybe a calculator of some sort could be quite interesting, or factorial? Let's do factorial, okay, that factorial method that we saw. So I'll say public int factorial, okay, factorial. And this is going to take in an integer called n, and it's going to return n factorial. You guys can remember that recursive method that we saw before. So we're going to say if n is 0, okay, if n is 0, then we're just going to return 1 because 0 factorial is 1. And otherwise, we are going to return n times by whatever factorial of n minus 1 was. Okay, n times by whatever factorial of n minus 1 is. Okay, so this will recursively go down through all of n and calculate the factorial. We've seen this method before back in chapter 1. Okay, and all we did now was mark it as a web method. What I'm going to do, I'll create another method here as well. Let's also keep this one simple. I'll say we'll make this one add 2 numbers together. So we'll call it add numbers. Okay. Actually, let's make it square so that they take in the same thing. We'll say power 2. We'll call it power 2. Okay, this is going to take in int n, and it's just going to return n times n. Okay, return n times n. Okay. So if you give it 9, it'll return 81. Okay, or any other example that you like. Cool. So we have our 2 methods here. Let's go see what this does. So I'm going to save that, Control S, build it, okay, build the whole solution, and we're just going to open up the web service in the browser, okay? So there we go, it's open. Okay, so you can see this is web service 1. This is a page that was automatically generated for us. We'll see how we can customize this page later and how we can customize the web service a little bit, just to make it look a little bit nicer or to do things slightly differently. But anyway, so you can see factorial here. So factorial is one of the methods, but you can see power 2 isn't here, guys. Why is power 2 not here? What would I have to change about the code to make it so that power 2 was available inside the web service? What's wrong with this code? Why is power 2 not visible inside our web service, guys? What do I have to do to make it so that power 2 would also make it a web method? Precisely. Yeah, exactly. So I just have to go over here and I have to say, oh, by the way, this is a web method. It must also be available inside the web service. Okay, cool. So I'll build that again. We'll go over here, refresh. And you can see that power 2 is now available because it was marked as a web method. Okay, cool. So we've got our 2 options here, factorial and power 2. Let's jump into factorial. Okay, cool. So it gives us this. You can see it's taking in a parameter called n. Okay, it's taking in a parameter called n. We can set n to whatever we want. Let's make it 6. We're going to invoke the method. So we hit invoke. And you can see we get 720. So it gives us back this response, and you can see it's a 720 there. It's inside this tag called int, so it's an integer. And yeah, there we go. So 720. That is indeed 6 factorial. Okay, so this is working. If we give 5, it's going to give us back 120, which is indeed 5 factorial. So yeah, that's working. Web service 1 is working. We can try out power 2. If we give it 9, it should give us 81, and you can see it does give us 81. Okay, cool. So that's working. Our web service is working. Those are our 2 methods. Fairly simple. But let's discuss just a little bit more in detail, like what's going on here. How is this page generated? How does it know how to communicate? Because the browser doesn't know C#, right? The browser doesn't know C#. How does it know to communicate in the structured way? So let's discuss that a little bit more in detail. Cool. So there's 2 components that make web services work. Okay. The first component is the WSDL, the Web Services Description Language. Web Services Description Language. As the name suggests, this is a language that we use to describe web services. Okay. So when a web server releases a web service, so like we just released our web service, or when Airlink, Sapphire, and Mango released their web services, what they did is they published what is called a WSDL. They published a document, WSDL. And there are a lot of ways to view the WSDL of various web services. We could, yeah, there's lots of ways to view the like the different WSDLs. We can, maybe we can view ours even. Let me just see. View in browser. There we go. For more details on the WSDL, see the WSDL specification. We can click the WSDL specification. And you can see these are, okay, this is how to create a WSDL. You can see there's an awful lot of instructions here. But yeah, ours was automatically generated for us. Here, please review the service description. There we go. This is our WSDL. Okay, this is our WSDL for our simple little service here. So again, it looks complicated, but actually when you read through it, it's fairly simple what's going on here, okay? So it says, okay, the name of this method is factorial. You can see it says name equals factorial. You can see that it takes in an integer called n. It takes in one of these integers. So it takes in a minimum of one of these integers and a maximum of one of these integers. Its name is n and it is an integer, okay? Cool. The factorial response, it returns a maximum of one response and a minimum of one response, and it is an integer as well. Okay, we've got power 2 over here as well. It also takes in n, that's an integer. It gives a response that is also just an integer. Okay, that's also just an integer. And yeah, so it looks a little bit complicated, especially for two methods, but that's exactly why it's generated automatically for us, because my gosh, typing this up yourself would be annoying, hey? But yeah, anyway, it's fairly simple what's going on here. Cool. So that's the WSDL. That describes the web service. That's how it knows what the name of the method is, how many parameters it takes in, what it returns, and how many things it returns. All of that kind of stuff will be specified in the WSDL. Okay, so it's also XML based, so it's very simple to read, as you just saw. And you'll see that later on, we'll discuss XML in more detail in chapter 6, the last chapter. So it's an XML-based language that describes web services, and the following would be mentioned in the WSDL of a web service, as you just saw. The data types that the web service can process, so like what it expects. Both of our web services expect integers, but you can imagine web services that expect strings, because any standard C# method can be turned into a web service. The methods that the web service has access to. So for example, our web service has access to two methods. They are factorial and power 2. And it also specified the URLs at which to access those methods. So what do I mean by that? If we go back to our web service, we hit factorial, we give it some kind of factorial, we hit invoke, it has to know where to find factorial, right? It goes to /factorial. It has to know where to find all of this stuff. Like how does it know where these web services are? It's because the WSDL specifies all of those URLs. Okay, so that's the one component. We have to describe the WSDL so that people are actually able to use our web service and like interact with it. And there's a secondary aspect as well, and that's called SOAP, the Simple Object Access Protocol. The Simple Object Access Protocol. So what SOAP is the protocol that defines the structure and rule of message exchange for web services. Okay, so that makes it sound like a little bit complicated, but it's actually very simple, and we'll read through an example now. The messages are also a form of XML, and they're transferred over HTTP. But essentially what SOAP is, it's pretty similar to like a HTML document. It looks fairly similar, except it's very much structured for sending a message. So instead of like, so we have like an envelope, a SOAP envelope, and inside an envelope, we have a header and we have a body. That's what SOAP messages look like. Okay, the header is optional because you could put like authentication there. So for example, let's say you didn't want everyone to be able to use your web service. And so if they want to use your web service, you send them a special little password and they have to make that password available in their header. That's the kind of thing you would specify in the header, like any kind of meta information. But the body is the main part of the SOAP message. That's how we send the data to and from the web service. So let me give you an example of this, okay? Using our little web service here, if I click on factorial, you can see it actually gives us the SOAP over here. That's the SOAP that we're sending across. So I'm going to zoom in a little bit. Cool. So here it is. We've got the SOAP message here. All of this is just sort of processing information, everything before it, not super relevant for us. This is the actual SOAP message. So you can see it says SOAP envelope. Okay, so that's just the container for the message. We've got a SOAP body. Okay, a SOAP body. So this is the main body of the message. You can see the method that we are contacting, the URL where that method is available. So we're contacting factorial. we are giving it one integer. The name of that integer is called n, and the actual integer that we give it itself. So here it's just a placeholder. This will be replaced. Like if I type 5 over here, this int, when I send it to the server, that's going to be replaced by 5. Okay, so that is the message that we are sending to the web service in order to contact the factorial method. Pretty simple, right? Like actually fairly sensibly structured. And if we go to power 2, you can see it'll be a very similar message. You can see here it's SOAP envelope, SOAP body. Power 2 is what we're contacting. That's the URL that it's available at. It's just n, that's the name of the integer. And the integer itself is over there. So like if I specified whatever integer, like 9, that int is going to be replaced by 9 when I send it to the server. Okay. Likewise, when I click invoke, the response will also actually be sent in SOAP, okay, like another SOAP message. You won't see the whole format of the SOAP message. Maybe if we, okay, yeah. So there's no full format of the SOAP image that's given to us. But yeah, the response is also sent in a similar way. Okay, cool. In fact, oh, you can see the response right here, right below it. So here's the response, the format of the response it'll send you. So if you request from Power 2, this is the message it'll send back. Power 2 response, Power 2 result is an integer. Okay, so it sends back that integer, and that's the end of the response. Okay, so there we go. That's how web services are passed along inside an envelope with a body and a head if you want. Okay, cool. Yeah, so cool. There's one more thing we have to discuss in the context of web services. And it looks like we might finish a little bit earlier today because I won't jump immediately into chapter 5. So this is the last thing we have to cover in relation to web services. Is kind of like you can see over here we have our web service, right? But you can see this doesn't look too great, right? This doesn't look too great. How we actually want to use web services practically, right? So if we jump back to our little Google example, like Cape Town to Johannesburg flight, and you can see that, so Google is contacting a bunch of different web services over here, right? They're contacting a bunch of different web services. And you can see that it's really nicely formatted, right? Like this is what our web service looks like. And also Mango and Airlink and stuff like that. If you access their web service directly, this is what it would look like. It looks pretty gross. Not really nice to use. Really, you want to be able to take this basic application that they give us here, this basic web service that they give us here, and we want to be able to translate it into our own application that we can customize ourselves, right? Like we know how to build web apps and websites. So if we take this basic application or this basic web service and translate it into our web application, that would be pretty great. So just like Google has done here, they take the horribly formatted web services of Airlink, Mango, and Sapphire, and they customize it a little bit to give it like this nice clean look in their own application. So how is it that they are contacting a web service from inside an application? How do they do that? They use what is called a web reference, And it's pretty easy to add a web reference to an application. So we're just going to actually go ahead and do it. Cool. So let's just jump into that. What we're going to do, okay. We're going to create a totally new project just to show you that this really is, it's totally divorced from this sort of part here. So cool. Let me just make sure quickly. I guess we could put the web reference over here. Let's add a new application over here. Yeah, let's do it that way. Okay, so I'm going to add a new project over here. We're going to call it AspNet web application. Yeah, that's fine. So we're adding an AspNet web application. So this is going to be web application 2. Okay, so this is a completely new application that can't do anything. And what we're going to do is we're going to make this application be our own interface for the web service that we just created. Okay, so we've got that web service up over here, web service 1 inside web application 1. And what we're going to do is make it so that web application 2 can access this web service in a way that we control, like we control the formats and structure of the way it accesses. Okay, cool. So I'm just going to add a basic web form over here. So we're going to say add new item web form. Okay, like so. Cool. So how we access a web service from a separate web application that we are creating, from like a client's application that we are creating, is we specify what is called a web reference. So that is a reference to a web service that is available somewhere. Okay, so how we do that is it's actually a pretty simple process, to be honest. What we need to do is say add, okay, not add a web service. We're adding a reference, okay, adding a reference, okay. Ooh, we're actually adding a service reference though. So let me just make sure I click the right one. Adding a service reference, okay. So a reference to a service that is available somewhere. You'll see, so this is the first kind of service we're learning about, is a web service, but there is other kinds of services as well. But cool, so we're adding a web service. This is a web service, so it's a little bit more advanced than a standard service that we'll be learning in the next lecture. And you can see there it says add web reference. So that's what we're doing. We're adding a web reference. Cool. So this is asking us for a URL. So we have to give it a URL. Let me just, okay, we need to actually get the URL for our web service. So what I'm going to do is just make sure that I copy that URL quick. So I'm going to open this inside the browser over here. Okay, so here's our web service URL. Okay, so now I'm going to do that process again. We're going to add a web reference to this little application here. So add service reference, advanced, add web reference. And now we're going to give it the URL that we want to access. So I'm going to go over here. Here's the URL to our web service, and I'm going to give it this URL. Okay, so there we go. Over there, and I'm going to tell it to go ahead and visit that web service. And you can see it visited it. This is what it got back. You can see there's factorial, there's private, there's power 2, and there we go. So I can just click add reference. Okay, done. Job done. It's loading a bit because obviously it has to add a lot. And you can see right here, we've got a web reference. Okay. Okay. Localhost is not really the best name for a web reference ever, but hopefully we can make it work. Okay, we'll make it work. Cool. So that's our web reference added to the application. But in order to actually use it, we're going to need to, I really should give it a new name. That is a terrible name for a web reference, localhost. Okay, anyway, it's not the end of the world. So we'll leave it like that. We'll leave our web reference with the name localhost. But you can see, so this is referencing the web service from inside web application 2. So I'm going to be able to use this as if it is a local class. And you'll see that now. So let's just discuss a little bit like what we need for a web service. Okay, so we need a text box. Okay, we need a text box where we can type the number that we're sending to the server. We need a button that we can click to actually send whatever we type in the text box to the web service. And we need a place where we can display the results that's given back to us from the web service. So those are the things that we need for our web service to work. We need a text box, we need a place to display the results, and we need a button. So if that sounds familiar to you, that's because it should be. So we're basically going to need exactly something similar to the previous application that we created, where we have a label, a button, and a text box. So what I'm actually going to do, just to speed things up a little bit, I'm going to go to our other application and just copy the label, the text box, and the button. Okay, so we've got the label, the text box, and the button right there. I'm going to copy that directly into our other web form over here. Okay, there we go. We've got a label, a text box, and a button. It's not actually doing anything yet. Okay, we still have to implement this on click. When you click the button, what we want to do is take whatever's in the text box and send it over to the web service. So let's go ahead and do that. I'm going to, cool, so we've got that. This is our new one. Okay, it's a little bit confusing because both of the web forms have the same name as well. Great stuff, really. Okay, cool. So we have to implement this method quick. So we're going to say protected button 1 underscore click. We have to implement that method. So button 1 underscore click, object sender, event args Okay, there we go. So this is the method that's going to run when our button 1 is clicked. And what we're going to do is just invoke our web service. Okay, so what we have to do initially, we have this local host here. That's a reference to our web service. We need to create an object of type web service, so of our web service. So what we're going to do is say var, what should we call it? Let's call it service, okay, service. Okay, oh, our service is probably a taken name. So let's call it web service with the lowercase w. Okay, so web service. Then we'll say equals, okay, it's going to be equal to new localhost dot web service 1. Okay, so let me just, yeah, so localhost web service 1, that's cool. Okay, so what's going on here? Localhost is referencing web service 1. Okay, so you can see inside web service 1, we have this class called web service 1. And so it's similar. So imagine that this class was called rectangle, for example. You know how we would create an object of type rectangle, right? We would say something like rectangle rect equals new rectangle. That's basically all we're doing here. Var just means we don't really know what type it is. C# is going to decide on the type for us. We're going to say, okay, web service equals new localhost web service 1. So what is that doing? It's going through localhost, which is the reference to the web service. So this web service could be anywhere on the internet, guys. It could be anywhere on the internet. And it's jumping over to web service 1, which is the class that has our web methods in it. Okay, so we're creating an object of that web service. Okay, that's all that's happening there. Okay. And then all we need to do is use the methods. So you can see if I go web service dot, if I say web service dot, you can see that factorial is there. That's our factorial method. And you can see that power2 is there. That's our power2 method. So now we just have to use those methods. Okay. So there's going to be some little issues that you guys are going to help me work through now quick. So when we fetch this information from a text box, what type is it, guys? Do you guys know? What type will be given to us by our text box? What type is going to be given to us by the text box? Anyone have any ideas? What type would you store inside a text box? Inside C#. So what type would it be? What type would we expect to get from our text box? Anyone know? No one have any ideas. What are the types that are available to us? What would be inside a text box, guys? We've got some text in there, some characters, some could even be numbers in there. There could be anything inside a text box. So how do we represent it inside C#? What type would it be? No one have any ideas? Okay. So it would be a string. Guys, a string would be stored inside a text box. So what we're going to say, so textbox1.text, textbox1.text. Okay, you can see that it is a string. Okay, a string. So textbox1.text is a string, but what type does factorial expect us to give it? This you should be able to answer. Factorial and power2, what types do they expect? What types do they expect us to give them? Factorial and power2. What do we have to give them, guys? Anyone? We just wrote up those two web methods. What types did they take in? Get and set. So what types did they take in? Getters and setters are how we fetch the property. But what types do, I mean, I can show you the web methods now. When we look at these web methods, what type do these web methods expect? What types do factorial and power2 expect to be given? Just read through the methods over there. What types do they expect to be given? So here we've got the definition, integers, exactly, yeah, integers. So our text box is giving us a string, okay? Our text box is giving us a string, but our methods expect integers. So how do we fix this? We have to convert the string to an integer. So how we do that is there's a class called convert, Okay, convert dot, and inside that class, there is a method called toInt32, and we can just throw whatever the text box gives us into this method, and it'll be converted to an integer. Okay, so there we go. That's going to convert it to an integer. So that's taking whatever's in text box and converting it to an integer. Okay, so that's what's happening there. Then what we're going to do with this is just give it to factorial. So inside web service, we can, through web service, through our web reference, we are able to access the factorial method. So I'm going to say web service dot factorial. Okay, and I'm just going to give it that integer. Okay, like so. Cool. So that's cool. Now we are actually going to have another problem. So the goal here would be to set label one, like this label up here, to the value that is returned by factorial, by the factorial method. So I'll ask you guys another question. Results will show here. So I'm going to ask you guys another question. When we get, what will we get back from factorial, guys? What type are we going to get back from factorial? Anyone know? If we look at the definitions of our methods there, what type are we getting back from factorial and power 2? What types are they giving us back? So you guys managed to see that they take in integers, right? They take in integers over there. What types will they give back to us? Yeah, exactly. They both give us back integers as well. But what type do you think label one.text is? Like, I want to change this text to the result returned by factorial in power 2. So what type is that? What type is text? It's a string, exactly. So we get given back an integer by factorial, but label one.text will want a string. So if I say label one.text, you can see label one.text is a string. So I can say equals, okay, cool. But you can see it's giving me an error. If I mouse over this red line that it says here, it says, okay, hold on, let me get the error. Okay, so the problem that it's having here is that factorial returns an integer. You can see that it says, we cannot implicitly convert type int to string. So factorial is returning an integer. As you can see there, it says int, that's the type it returns, localhost.webservice1.factorial. So it's returning an int, as you can see at the beginning of the line. So we need to convert it back to a string. Luckily, C# provides a way to do that. We can just say toString. Okay, toString. So whatever comes back from this, it'll be converted to a string. Okay, and now we'll have no problems. So what I'm going to say, I'll save that. We're going to build everything. Okay, then we're going to open up our web service, our web form, sorry. So we'll open up that in the browser. Okay, sorry, it was still building. Okay, there you go, finish building. We're going to view this web form in the browser. It's the first time we're opening it, so it's going to take a little while. And okay, there it is. Okay, so this is our web form. We can give it a number, and when I hit submit, you can see it gives us the result of the factorial web service over there. So this method is going all the way to the web service and fetching the response for us. Okay, so yeah, there we go. That's how you add a web reference to a client's application. That's how we access web services inside clients' applications. Okay. Not too bad. And yeah, so cool. That's that. So that's how we access web services and clients applications. And that actually brings us to the end of web services and to the end of chapter 4. We're making very good progress. So it looks like we will have some time for revision at the end as well, which is good, I think, since a lot of people are missing. So yeah, next week we'll start chapter 5, which is on desktop applications. So it's sort of discussing, you know, like, how is this Zoom application made? How is this made? How is the Epic Games or Steam application made? And the answer is that they are Windows forms. They are desktop applications. So that's what we'll be learning about next week. And yeah, you can see we are nearing the sort of end. We should finish at the beginning of November around, perhaps. So we'll have lots of times for revision. I think we will do some sort of, since you guys have 20 minutes extra, I'll suggest, could you guys go through, there's a knowledge assessment that starts on page 115 of your textbooks, of the PDFs that were sent on the WhatsApp group, the chapter 4 PDFs. If you could go through the questions and make sure that you're able to answer the ones for chapter 4. Okay, so the chapter 4 knowledge assessments, and then I'll release the solutions to you guys at some point later on. I'll give you guys the memo. Okay. Cool. But other than that, I think we can finish early because I don't want to start a new chapter in the last sort of 15 minutes. Yeah, and hopefully attendance will improve next week again. Cool. But anyway, yeah, thank you guys for coming. See you guys next week. That's the end of chapter 4. Wow, we have been making good progress.
Thank you, Josh. Enjoy your weekend.
Yeah, thank you, Taffy. Cheers. Enjoy yours as well. Cheers, everyone. Cheers, Chris. Cheers, Chico. Cheers, Tejo. Cool. Enjoy your weekends. Yeah, thank you for coming. And yeah, see you next week. Okay.